Data from the Hubble Space Telescope has indicated that there is a concentration of small black holes at the heart of the globular cluster NGC 6397. While scientists were expecting to find an intermediate black hole at the heart of the globular cluster NGC 6397, they, however, managed to find a concentration of smaller black holes lurking there. Based on new data gathered from the NASA ESA Hubble Space Telescope, this indicates that the first measurement of the extent of a collection of black holes exists in a core collapsed globular cluster. Globular clusters are extremely dense stellar systems in which stars are packed so closely. They are also very old systems. The globular cluster that is the focus of this research is NGC 6397. It is almost as old as the universe itself. Currently, NGC 6397 resides 7,800 light years away, making it one of the closest globular clusters to Earth. Because of its very dense nucleus, it is known as a core collapsed cluster. When the research team started the studying of the core of NGC 6397, their expectation was that they would find evidence of an intermediate mass black hole. These are smaller than the supermassive black holes that lie at the cores of large galaxies, but they are larger than stellar mass black holes that are formed by the collapse of massive stars. This intermediate mass black hole is a long sought after missing link in black hole evolution, and their mere existence is hotly debated. Many persons, along with scientists, believe, though, that they have found many potential candidates to look for the intermediate black hole. The team analyzed positions and velocities of the cluster stars. They did this through the use of previous estimates of the star's proper motions from Hubble images of the cluster spanning across several years. In addition to proper motions provided by the ESA's Gaia Space Observatory, which precisely measures the positions, distances, and motions of stars. Knowing the distance to the cluster allowed the astronomers to translate the proper motions of these stars into velocities. The analyses indicated that the orbits of the stars are close to random throughout the globular cluster, rather than systematically circular or very elongated. According to astronomers, they found very strong evidence for invisible mass in the dense central regions of the cluster, but they are quite surprised to find that this extra mass is not point-like, but extended to a few percent of the size of the cluster. This invisible component could only be made up of remnants, that is, white dwarfs, neutron stars, and black holes, of massive stars whose inner regions collapsed under their own gravity once their nuclear fuel was exhausted. The stars progressively sank to the cluster's center after the gravitational interactions with nearby less massive stars led to the small extent of the invisible mass concentration. Through the use of the theory of stellar evolution, the scientists concluded that the bulk of the unseen concentration consists of stellar mass black holes, rather than white dwarfs or neutron stars that are too faint to observe. Two further research had also proposed that stellar remnants, and in particular stellar mass black holes, could populate the region of the globular cluster. Their study is the first one to discover and provide both the mass and the extent of what appears to be a collection of mostly black holes in a core collapsed globular cluster. Their analyses would not have been possible without having both the Hubble data to constrain the inner regions of the cluster and the Gaia data to constrain the orbital shapes of the outer stars, which in turn indirectly constrain the velocities of foreground and background stars in the inner regions. This data is very helpful, and it attests to an exemplary international collaboration. The astronomers also advise that this discovery raises the question of whether mergers of these tightly packed black holes in core collapsed globular clusters may be an important source of gravitational waves, recently detected by the Laser Interferometer Gravitational Wave Observatory experiment. Like, comment, share, and subscribe. Let me know what you think about this fascinating discovery of small black holes at the center of a globular cluster that is approximately 7,800 light years away from Earth. It is the closest globular cluster to Earth. And of course, we anticipate and we wait patiently for more discoveries from our astronomers who continue to utilize amazing space technology and spectacular analysis skills to determine what exists in the universe. Have a wonderful day. Goodbye.